So, hello everyone, and welcome again to another Saturday Microscopy live stream. I'm Oliver, and yes, as always, I have to do a little bit of housekeeping. Yes, okay, I can see myself, and I think everything seems to be running again. It's not always guaranteed that everything works out right away. But I think we're fine now. First of all, hello again around the world. Today, I mean, this has already tradition, right? It's I'm in Central Europe. It's fall. Leaves, are basically down from the trees now, and it's time to do again another, like every year, a little leaf preparation, a microscopy lab, and we're gonna see how far we get. I decided not to stress myself. We'll see how much time it takes. We're gonna see which questions appear. If for whatever reason, I don't know, we end up being very quickly or we're getting bored very quickly, I'm going to show you a vitamin C reaction with some starch from the potato and iodine. It's also kind of interesting. But if not today, then well, maybe next time. Okay. So as always, I want to say hello. Around the world, there are already some questions over here. Galvanotaxis. I can try that again. Basically, that's when paramecia are in an electrical field. Hello from Oregon. Okay. Just saying hello all around the world. I'm just going down here. Otherwise, I'm just gonna send a general hello all across the globe here. From Netherlands, from Vietnam, from Wales in Austria. Okay, from the United States, England, London. Okay, very nice. Okay, and from Germany, of course. Yeah. So what we're gonna do is the following today. I need this is I would say quite a nice little activity, and it's a little bit meditative, I would say, because it does take a little bit of patience and a little bit of time, and and what you need to do is in preparation is you need to collect a few leaves. It doesn't matter if they're already a little bit dry or not. They can also be reasonably fresh, and you have to boil them for a few hours, right? At a low simmering temperature. I think I boiled them for around 3 hours or so, and they become all soft. And then what I'm going to do is you need a brush here, and you need to strip away the layer of cells until you have a so-called a leaf skeleton. And this leaf skeleton we're going to put under the microscope, and I also would like to make, of course, some permanent slides. Yeah, because why not? Okay, so this is also a nice, I would say, school activity that one could do with students or with children. Disadvantage, it does need to boil a few hours, right? And not every leaf is suitable. It's really important. You got to try this out in advance, because some leaves, like oak leaves, they do not work at all. Okay, so this is basically the thing. Yes, I see. If you have any how do you say, any comments or questions, please write it in the chat, but indicate also at Oliver or at Microbehunter, ideally at Microbehunter, because then it's highlighted red and it's easier for me to see. Okay, so where we're gonna get started? That's what looks to be a maple leaf. I boiled it for a few hours. You add a little bit of water here. Okay, and now, by the way, I've got another one over here as well, right? It looks pretty disgusting, but that's just because the layer of cells has been boiled away, and we're going to strip the remaining with a brush. But actually, having said that, why not try the following? I mean, after all, this is a microscopy. After all, this is a microscopy live stream. So let's put it under the stereo microscope first. And let's see, I don't know what we're able to see here. It's, the magnification is of course still a little bit too high, and all of the reflections of the water. But what we're already able to see is if you're able to see those fine, I'm able to point here, here. If you're able to see this fine network here, right? These are so-called the leaf veins, the vascular tissue of the leaves, and we would like to isolate that, right? So this is, the thing, and we can basically extract those by stripping off the remaining cells. Then I'm going to do a destaining with alcohol to remove any pigment, and then let's see if we're able to do a permanent mount as well. Okay, a couple of years ago, I really spent, I don't know, almost a couple of hours really to completely nicely strip away of a full leaf. I took a very nice large leaf and I managed to strip away everything. This took a long time, and we don't need that because we actually only need a small section, right? So, and this is going to be a very, how do you say, I always say meditative, relaxing, a little afternoon activity, evening activity. What you do is you just basically try to carefully strip it away. And this leaf over here is, I don't know which leaf, honestly, I don't know which leaf it is, but this leaf over here is extremely easy to process, I found out. Look at this, right? Yeah. And what you see over here, this is already the end result. This fine mesh that you see here. These are already the leaf veins, yeah, and it's actually, you have to be really, look, it rips quite easily, yeah, so you have to be really careful here. The maple leaves, the others are not quite as sensitive, yeah, but we're already, actually, yeah, we're already finished, almost. So what I have, you know what, I'm going to make it a little bit bigger. Yeah. So, and then you take you take a brush here, you try to carefully strip away. Here it doesn't go because there seems to be a... let's see. Here. See that? Yeah. It kind of rips quite easily here. But what I'm going to do now is the following. Is I'm going to simply take I'm going to try to put this thing here with a scissor. And let's try to carefully put those things here. I'm going to make it again a little bit smaller here. Yeah, on let me put the microphone away a little bit here as well. And now I somehow have to be very careful. Let's try to cut it. And I don't know if I'm able to manage this even, or maybe use the brush to kind of transfer this. No, see, that's already a difficulty. I'm going to do the following. I'm going to simply remove this here. See, I've got another leaf over here, and this one also doesn't quite work as easily. But I have an idea. Why not try to do the whole thing directly on the slide? Okay, let's see if this actually works better. And patience. Yeah, sometimes just a few millimeters are enough. Okay. And let's remove this here. And I'm going to put this directly already under the microscope. I know it's not a... Yeah, let's careful to do this. And maybe if we can look at this part over here. And then let's see if we were successful. This leaf was quite thin and is quite delicate. But let's have a look. Okay, I think it should have worked. And I'm going to go into the scope view, the microscope view, without cover glass, without anything now. Okay, using a low power, and I have to kind of find it first. Here we go. Okay. But actually, looking at it, could have been a little bit nice. Here, maybe it's here. It's a little bit better. But these are actually these do not look like the leaf veins very much, honestly. This is not nice looking. Okay, a little bit here over there, maybe. Yeah. Let's go up yet more. This is not nice looking. Here we go a little bit. Yeah. You see maybe those, whatever is left of the cells. But honestly, the maple leaves look way nicer. Here it's a little bit better. Yeah. But it is a very delicate, these don't look like, I've seen nicer samples here. Yeah. Why can't I use my oak leaves for this? Because I tried it and they would not strip off the cells. I could not get it off, right? So maybe what I would suggest, and there are recipes online that suggest that you have to add baking powder to it or some kind of a base to remove it. I tried it with oak leaves, but they were too stable and I could not strip the cells off, right? So that's a little bit the thing here. This honestly... I agree. This does not quite look like the. This looks indeed like the epidermis, and not like the how do you say the. Maybe we indeed caught the epidermis here. That's interesting. Let me try it again. The oak leaf, not the oak leaves, the maple leaves actually do work a little bit more easily. Because this one here is a little bit, indeed, a little bit too. It's kind of interesting. Let's have a look if this is a little bit more successful here, or if I'm only looking at the epidermis here, which would be actually quite nice, because if we could actually see it in the stomates, this would actually be also quite revealing. Okay, let's try it again. Honestly, I think these are not the. This is actually what we're looking at, is indeed the epidermis here. Interesting. Didn't expect that either. But usually putting a leaf directly under the microscope, of course, is not going to work because it's way too thick. Look, stomates, of course. Okay, no leaf veins, no leaf veins, but lower epidermis. Here we go. But actually also quite how do you say, good to know. Honestly, what about grape leaves? So basically, try it out, please, by all means. I've got pretty good results with maple leaves. What about staining? I'm going to try to stain them as well. Don't worry. I'm going to use now I've switched over to crystal violet because it's a very strong and powerful stain. But you can try whatever. Ink should also work. So, and again, you have to try it out a little bit on how well it's able to actually strip off the cells, right? So you know what, you get the idea, and now I would like to have a look at some of the. Let's zoom in a little bit more. You see that over here I already tried it a little bit. So look, these leaves here. I think I was not quite as successful with those. Sometimes I'm bumping into the camera. And if the brush is too soft, it's not gonna work. If it's too hard, you're gonna rip the leaf. And sometimes you simply have to be very patient, slowly, simply stripping off cell by cell, and then you slowly can see that it starts to become a little bit more transparent. You might want to flip it around, but again, over here you see that this leaf also does not quite work quite as well as I hoped it to work. This was a little bit a demonstration to show you that not all leaves are equally suitable. Okay, but over here, this one, for example, if you just go like this, you can actually see that it does become brighter and brighter and brighter, and then you want to flip it around. And you want to try it on the other side as well. And here the results generally are quite good. There are also a not so nice possibility how to do that is you simply allow the leaf to slowly decompose. You put it on soil, keep it moist, and allow bacteria and fungi to decompose it. And they have a much more difficult time to decompose the harder vascular tissue, and therefore you will also have a network left over. So what I'm doing right now is I'm just going to flip it over. I'm trying it now with on the other side. You see how all of this material is stripped away. I mean, honestly, please do try it with all sorts of leaves. Be aware that some of the leaves are really going to rip very easily. Don't be frustrated. Try a different leaf, right? And other leaves, you won't even, they're so stable that you won't even able to strip any cells off. What I've also done is the following: when you boil those leaves, then the water looks horribly disgusting. It will look brownish, blackish. I've exchanged it usually then once. It doesn't really matter. So what we have now is the following. We have now got a fairly, actually, you know what? We don't need the whole thing. We're just going to remove this here. Look, that's what we got. And when you look at it, and especially after it's dried, it's surprisingly stable. Yeah, so what you do is you rinse it with water, and then you put it on tissue paper, and then you make sure that you put another layer of tissue paper on top and you press it flat with a book. Yeah, otherwise it's gonna shrink and so on. But once it's dry, it's surprisingly stable. Yeah? So what we're doing right now is the following. Yeah, again, we're just going to do the following. We're just gonna take a how do you say, a slide here, and we're just gonna cut it off or rip it off, doesn't matter. See how, we're gonna put it on here. And this is also a little bit of a quality check. And this is not perfect. You see there's still a lot of stuff sticking on here. But if you then exchange the water a little bit, and then if you rinse it and you brush over it again, you can get a pretty clean, network. And then basically, we can observe it. About the oak leaf, if you freeze it and defrost it, would it work? Or the ice crystal, would that be too much damage? I have to tell you, I have not tried it. And I really, honestly, thank you for the suggestion. I could try it. Maybe adding trying to boil it in vinegar maybe to soften the cellulose, or in sodium hydroxide maybe, I don't know, right? In any case, unfortunately, I was not successful with oak leaves, even though they would look kind of nice. But maybe it's just a question of preparation. Yeah? So no cover glass, no nothing. I mean, I could add a cover glass. Why not? But you know what? I'm impatient and I just want to see how it looks like. So this means the scope view, and here we gotta turn it down here, and this is how it looks like. Okay, let's go down with the magnification a little bit. Yeah, and I think it looks, quite nice. Yeah, so especially as a little bit like modern arts. Yeah. Would hydrogen peroxide dissolve the skeleton? That's a good point, actually. Yes, it would, because it is organic, but it might not dissolve it as quickly. So maybe it's gonna dissolve the soft cells first. Because and then if you take it out quickly enough, that would be actually an interesting point. Yeah, can I polarize it? Actually, I do have what I have right now is actually polarized light. Okay, so I have to but it's not cross polarized. So you see over here, but that's the DIC. How do you say the DIC? The optics that I have. On the regular bright field, it would look like this. Yeah. You see over here, there are all these. It's not a perfectly clean. Preparation. Just show you why. Over here, because here, where's just a second, the arrow. I have to. Here it is. Yeah, because you see over here on the side here, these are all still some kind of loose cells that have not been completely scratched away. A couple of years ago when I tried this the first time, I really did this very carefully. I got really nice, smooth corners here, but it took a couple of hours. Yeah, carefully. Yeah, so that is try a more delicate brush as well. Yeah, and what you have is, if the brush is delicate, you simply have to try it several times. Yeah. So, but you know what? Why not? For the fun of it, I have also another leaf over here, and then let's try making a little bit of a, I don't know, how do you say, a permanent mount, or a staining it. Yeah. How long did I boil it? Well, I boiled it for approximately 3 hours, and just that it was a little bit boiling. And at what temperature? Well, that's an easy one to answer. It's going to be 100 degrees Celsius, because this is the temperature of boiling water. So as soon as it boils, you just turn it down so that it continues to slowly boil. You put a lid on top to reduce the evaporation. And then you're actually able to feel it. If you're able to take it carefully out, allow it to cool a little bit, and when the surface starts to become slimy a little bit, right, and things start to come off like this, then you know that you can stop. Yeah. So this is basically So I know it looks kind of disgusting, right? But that's okay. Yeah. So what we can try is we can try to strip off some cells over here. Yeah. And you will see that it will, of course, start to become brighter as as the leaf becomes thinner. Yeah, and luckily we don't need to prepare the whole leaf. So what I can do, actually, I mean, this would make it easier. Look, don't look. I'm just going to do it in a very easy way. I'm just going to rip this off here. Yeah, simply so it's easier for me to do something with it. I'm gonna just change the plate here. Add a little bit of water. Yeah, and that's it. Yeah, and as a matter of fact, if you don't want to do that, honestly, if you you just go to Amazon and you search for so-called leaf skeletons, because they are also commercially available for decoration purposes, and people buy them to make their own greeting cards and so on. Yeah, so these things actually are also ready-made, commercially available. Yeah, so I've not bought any of those. No, actually, I think a long time ago I did buy one for as a trial. Yeah. So, and yeah, just keep on doing this. And when you feel that you've removed most of the cells, then you simply flip it around. And you try it on the other side as well. Usually it does turn a little bit brighter as well. See, it does turn brighter. I'm always a little surprised how extremely stable this leaf is, because those leaf veins which transport water and nutrients, yeah, after all, do also serve important structural purposes for the leaf. So, and I recommend that if I mean, let's put it this way. Let's go a little more. Why am I even doing this? You see, it's not only about it's nature observation in connection with microscopy. It's a hobby, obviously, and the thing that kind of personally fascinates me all the time is still this incredible beauty of nature and the patterns of nature. It's just a certain, how do you say, aesthetic appeal. And you just watch and see nature differently. And we're every day I'm stepping over those leaves, right? They fall from the ground, they're on the street. But actually, if you look at them, in a slightly more, under the microscope, So what I'm going to do now is the following. I'm going to show you something. I'm just going to put it over here. And I've got a Petri dish here. And I'm just going to cut this off. This is more than we ever need. And it does look, kind of brownish. And look, just a second, do we have, and of course there's still some cells, on here. Yeah, so it's honestly, it's probably not a perfect, but you know, what do? I just removed some more cells maybe. And then I'm going to add a little bit of alcohol, simply to destain it a little bit, but let's get some more of these cells off. But I think it's kind of okay already. Again, if you want to do this yourself, you're probably gonna take a little bit more time. Here in the live stream, it's a little bit more like a proof of concept or some kind of demonstrations that I'm doing. You see, barely. So I'm going to pour it off, and now the next part starts. And what I'm going to do now is, where do I have it? Here it is. I'm going to just put some regular alcohol over it, and I'm going to allow it to soak for a couple of minutes. And what's going to happen is the following. It's going to start to slowly brighten up, and some of the pigments are going to be leached out because of that, and everything starts to become a little bit brighter. Yeah, so I'm just going to wipe everything here. Yeah, and we can basically, while we do that, and we maybe if we're lucky, we should be able to see how the alcohol slowly starts to leach out the pigments, and then it's going to slowly start to discolor around here. We're gonna see how well this works. Okay, so in the meantime, I'm just gonna go through your the how do you say, the chat, and Yeah. Off topic, I wonder if you used conductive 3D printing filament to make a conductive path. Would the microbes follow the actual path rather than just the current direction? Are you telling me there is conductive filament? I did not know that. No, oh, that's interesting. That's really interesting. No, that is really interesting. A couple of months ago, years ago, whatever, it is possible if you have paramecia and you've put electrodes on the slide, then they're going to move, I think, towards the negative pole. But I did not know that there is actually also conductive filament available, because this would actually allow me to 3D print something directly on a microscope slide. And yeah, so this would be kind of interesting. Didn't know that. Why can't I use my oak leaves? I was not able to manage it. Okay. So what chemicals can we use to stain it? I do have a couple of chemicals somewhere, or I forgot where I put them. Yeah, in my cupboard, which we can try. Yeah, so I would always say try regular household stains that you have, food coloring, intensive food coloring, or ink. Yeah. Grape leaves, grape leaves, I don't know, why not? Never tried them, okay? With hydrogen peroxide, I talked about that. Don't leave it in there too long. I did not try hydrogen peroxide. Yeah? I boiled them around 3 to 4 hours. Yeah. You can make 3D printed multi-layer circuits. I didn't know that. Okay, low current, otherwise the plastic will melt. Actually, I don't even need a lot of current. Actually, I only need a voltage, because then some of this would be interesting. Yeah. So let's see a little bit. Yeah. It's not. You know what I'm doing right now as well, just because it's possible. And why not do the following? I'm going to also try to strip a little bit more from this leaf over here, and then let's also put it into the into the alcohol. This one leaf was already dry. Another thing that you might want to try is the following: fresh leaves versus dried leaves. Unfortunately, I waited too long. Both of them were already dry. This one here, the brown one, was extremely dry already. So it might, maybe fresh leaves are easier to process. By the way, that might also be a thing. Maybe with oak leaves, let's try fresh ones and dried ones. Maybe this also makes a difference. Not, yeah. So let's have a look here. Yeah, I'm going to remove this here. Look how strong this is. Okay, let's put this away here. I need a little more water. Let's see. And I'm going to turn this around. Other side as well. Okay. Let's do this a little longer. Maybe we can make it slightly cleaner. I don't know, but let's just, it's all trial and error. Other one as well. Okay. Okay, so this is how it looks like. It looks pretty decent, I think. Okay. Yeah. So, and let's cut this away. And let's put it also directly into the alcohol. Look, it actually looks so much nicer, this one here. Yeah, it looks so much nicer. Yeah? Because it looks so much nicer, I'm just going to do the rest as well. Yeah. Yeah, let's just do the rest as well. And we simply have more sample material to work with. And so it's a very relaxing activity. During a very fast-paced times, a little bit of relaxation also doesn't hurt. So you can actually see how it slowly turns brighter. And then you just flip it around and try the other side as well. Yep, look. Here we go. Up, you cannot see it because I'm a little bit off the center of the screen. Okay, so looks nice. I think yeah, looks much cleaner than the other one. So as so often, trial and error I think is the way to go. Yeah. Oh, vegetarian, vegan meat. I still have you're commenting now on a couple of months ago. I bought myself in the supermarket all sorts of vegan meat and put that under the microscope. Wow, I was surprised how much microplastics or fibers I found there. Of course, you probably want to stain them to make sure that these are indeed microplastics that I found, but yeah, but because these are soy products, so I guess on the soy field, there were probably microplastics introduced by rain. So we're eating this stuff quite a bit, but this looks okay. Again, I will move it a little bit off. Yeah, I'm going to quickly rinse it again. Yeah. Try it. You know what? You know what I'm gonna do? Look, this is pretty messy now. So you see all those cells, yeah. So let's put this away here. And what do you tell me? I might have to condition it by electroplating. You're talking maybe about the microscope slide or electroplating those leaves here, which will also be. So let's do the following. Just for the fun of it, I wanted to have a look under the stereo microscope. Yeah, this is one of the things here. The surface of the stereo microscope is not the nicest. So let's have a look here. And so, yeah, it looks okay. I think it looks, at least under the stereo microscope, it looks kind of decent. I have not properly adjusted it, so it always goes out of focus when I zoom. Normally should not do that. Yeah, but that's okay, I guess. So I'm going to also try to destain it a little bit by placing it into for a couple of minutes into alcohol. Here we are again. Okay. I mean, honestly, I do have to admit something that I've had also leaves, and maybe because they were fresh and green. When I destained them, I could actually really see how the alcohol removed the pigment. It really, it's not so strong over here. Yeah. So maybe a few more minutes, but slowly I can at least see slowly the alcohol turning a little bit yellow and brownish. But yeah, with other leaves, this effect was way stronger. Yeah. Okay, I'm just going through a little bit the how do you say the comments as well. Okay. Okay. Yeah, here's the question. Just out of curiosity, have you ever found microplastics? Yeah, a lot. So also, for example, when I take some pond water samples, some from the sediment, usually you're always going to find some fibers. Usually, and as a matter of fact, it's a big source of microplastics is clothing, right? Because the so-called the synthetic fibers, and when you wash your clothing in the washing machine, then those synthetic fibers are being rinsed out, and then they actually go into nature, and they cannot be decomposed. I don't mind cotton fibers and cellulose. They will basically decompose after some time. But those microplastics fibers, because of polyester and I don't know, nylon maybe, essentially they do not decompose quite easily, and that's why if we find a lot of fibers out there, then they're microplastics. Something I have not tried yet, I've been planning as well, is, I know I'm sidetracking now again a little bit, but you can actually check under the microscope whether a fiber is actually made of cellulose, cotton, for example, or plant material, or whether it's synthetic, and this is by doing a so-called a hot needle test. You're heating up a needle and then you touch the fiber, and if it starts to basically melt, then you know that it's a synthetic fiber, microplastics. Yeah, if it scars, scorches, or if it burns or turns brown and does not melt, then it's it's usually cellulose. Yeah, yeah. So yeah, you see that slowly it's starting to turn a little bit yellowish, the whole thing. Going up. Wrong alcohol. No, not alcohol. I actually I mixed up the bottle and added a little bit of water. It's gonna. This is not more alcohol. So I just want to also give you a little best practice warning. What happens now if you take it out from the alcohol and allow it to dry? Horrible. It's going to completely shrink. I can actually try to show that to you. You can actually then put it back into water again to kind of get it into normal shape. But if you take this out here, and let's do that and place it on here, then of course it's going to dry very quickly because alcohol is volatile, it evaporates, but then it also starts to shrink quite a bit, and you're losing the natural shape, but you can restore it by again adding a little bit of water. I just want to show this to you as a demonstration. Yeah, at least this is what happened to me once. When I tried to prepare leaves, then they were all kind of much smaller. Yeah. The hot needle test is an official test. It's not something that I invented. Yeah. You can. What you can do is also there are so many projects on my mind that I did not try yet. Again, I have to wait for the holidays a little bit. But what you can do is you can take a water sample, potentially containing microplastics, and then you add it with salt, just regular table salt, and this causes the microplastic particles to float to the top. So that's a kind of a density separation method. Right, and then you collect the layer of water from the top, and because when you add salt to the water, then it makes it more dense, and the microplastics are less dense, so they start floating, and then this way you can extract it. Yeah, and then you can, under the microscope, you can use a dye to test for a fluorescent dye, or you can try the hot needle test. The thing that I don't know yet is how do you actually keep the needle hot? So maybe you want to connect it to soldering iron. I don't know. Yeah, so that is a possibility. Huh? Yeah. This one is still a little bit moist, I guess. I guess it has retained a little bit of moisture because this is not pure alcohol. Yeah, there's also still some water in there as well. Yeah. So let's do the following. Let's you see I don't know. It has turned slightly yellowish. Yeah. So let's do a little bit of staining. Okay. Why not? You see it's slowly starting to shrink maybe. You see it doesn't, it's not as flat anymore. Yeah. And you can restore it by adding it again into some water. So maybe I'll do that then later again. So what I therefore have to do now is I have to remove this alcohol, and I have to rehydrate those leaves because I do not want them to shrink, obviously. Yeah. So how am I going to do that? I need here's my trash can. Okay, I've always got this jar here. Maybe not the best jar because it's so high. Here we go. So, and let's add a little bit of water again. So to prevent, look, now it starts really shrinking. Yeah? So, and look, that's what I meant. Yeah, it loses completely its shape and not so nice anymore. So in order to do that, let's put it also back in here, and maybe it's going to regain its original shape again. Yep, here we go. It does. So now what? How do I stain this? I need a stain. Let me see. I got them over here. Here they are. The most foolproof stain is maybe Löffler solution, which is methylene blue, or very, yeah, very strong is crystal violet, which I recently started using. It's a little bit of a very, very intensive stain. How am I going to do that? What's the best way to do that? Maybe I need a little, yeah, tiny petri dish here as well. Let's try the following. Let's do this. And let's cut it off. It goes in here. And crystal violet is very, yeah, intense. Look how it actually follows. I've got an idea. I've got an idea, folks. Let's try this just for the fun of it. This is a little. Let's try it. I never tried this before. I don't know how can I do that. I don't even know if it's gonna work. Let me dry this leaf here. Let me dry this leaf a little bit. And I'm going to do an experiment now, and I really don't know whether it's going to work, okay? I really don't know whether it's going to work. I need another container. I don't know. Who cares? I'm just going to use this here. It's blurry. Here we go. I'm going to try something. I'm going to put a little drop here on the side. Yeah, and no guarantee. Let's see if the leaf is able to take up the stain. If I dump it in, put it in here. I don't know. It would be kind of interesting to see whether it's able, whether the stain is actually able to travel up the yeah. I don't know. Kind of interesting to see if this actually were to work. Yeah, I mean, it does stain this part here. You know what? Just for trial, I'm gonna put this here under the microscope and see if it's maybe traveling, yeah, along the. So let me see. I need to change microscope view. Scope. It's way too bright. And it's way too bright. Lower magnification. Ooh, look. Well, I don't know. Yeah. So here that's the unstained part. And this is the stained part. It's pretty dark. It's pretty dark. Yeah, I don't know if it, yeah, see, I don't know if it's possible to see that. Yeah, I'm just gonna stain it normally, I guess. Yeah, and so what I have here is, where is the desk view? So this is now the thing here, and now I need to destain it a little bit. I would like to remove all of the excess stain. And how do I do that? By simply adding some water. Taking out the leaf. Ooh. And removing the rest here. I'll do that again. Let me quickly. Yeah, it would be kind of nice to have a little bit of running water here at the table, but that's not possible. So let's do it like this. Okay. Yeah, and let's wash it again. And yeah, what I'm going to do now is I'm quickly going to simply try to make a permanent mount using this. Okay, so let me put the leaves here carefully to the side. Let's take it out. Let's remove any excess liquid. Any excess liquid. And I'm going to cut this part here. because I want to have a small part. Okay. Yeah, so here it is. And I would like to mount this here on this slide using my favorite mounting medium, which is simply glue, the water-based glue. You put a small drop on here. This is PVA glue. It's Elmer's PVA, diluted down a little bit with water. And I end up coming back to that one over and over again because it's readily available, cheap, and water-based. Look, this is actually quite nice. It actually really is soaked in quite nicely. Plus, at the end, I've got some round cover glasses here. I don't know if you're able to see this. Just going to drop it on here. Oh, look, my desk is already pretty dirty. And allow the capillary action to do its job. Maybe we can help a little bit by carefully pressing down. And then normally you would, allow it to dry for, I don't know, a couple of days maybe. There is no or very little glue on the side coming out. Otherwise, you have to be careful. Otherwise, you're going to get the glue on your microscope objective. You don't want that. Yeah, and let's give it a try and let's see how well this actually worked. Okay, and so let's exchange the slide and the scope view here. And now, of course, with the cover glass, we can go up with the magnification way more. It's a little darker. A couple of bubbles, who cares? Yeah, 4 times. We can now see the blue color. Yeah. Okay. Of course, you don't have to stain it. Of course, we can also see now on all of those places where I did not remove the cells, stripped off the cells properly. So you see, yeah, it's much more fuzzy over here compared to over here. So, yeah. Okay. Yeah, another topic that has already been covered. Yeah, sooner or later, I end up repeating the things. If you have any suggestions what you want me to do and put under the microscope, please make suggestions. I'm very happy to do that. Occasionally, my students make suggestions. Last week, they suggested that I put some sushi under the microscope, so I have done that. And for me, those leaves, I do end up coming back because occasionally, sometimes there are people who have not seen that yet. Yeah. Galvanotaxis, yes, definitely, thank you. I have also done that already before. As a matter of fact, twice already. Once it did not work properly, but galvanotaxis, I actually did buy myself a, how do you call this in English? A power supply unit, up to 30 volts. And I was able to move the paramecia back and forth this way. Yeah, so this is certainly something that I can do again. The only thing that I need to do is I need to grow myself a couple of paramecia again. So here you see how the stain is bleeding. But then again, another thing that I want to try probably with galvanotaxis is look what I've got here. Also, that's something, these are my nematode worms. And maybe they also respond. The nematode worms have a simple nervous system, so of course they're going to respond to electricity. Yeah. So this is certainly something that I could also try. Yeah. Yeah. So. Yeah. So this is basically a little bit of a thing here. Was the sushi delicious? Yeah. I have to tell you the following. Yes, they still were, but borderline. I need to tell you why. After I bought the sushi, I immediately, I'm talking about last week's live stream for those of you who don't know. It was like this, that I bought some sushi, I put them immediately into the freezer, so because I wanted to store them for the next day. because I've seen that the sushi restaurant used freshly cooked rice, which was not entirely cold yet. Yeah, and that's of course risky. You do not want to have food, especially not raw fish, which is in contact with warm temperature. You don't want that, right? But they of course assumed that I'm going to be eating it right away, so I immediately put it into the freezer, and that's why the rice did not taste very. How do you say? It was very hard already and dried because of the freezing. Yeah. So, yes, so what I'm going to do that now is, this is basically what I wanted to show you, very quick look under the stereo microscope, and then because some people want to see something new, then let's have a look at the vitamin C starch iodine reaction with some potato starch grains, okay? With darker structures, good point. I only have dark field for my 4 times objective. So let's see if I'm able to get that done. That would be, that's dark field, right? And yeah, you see, that's, I only have it 4 times, because what I'm using right now actually is the so-called the phase contrast annulus, which can be also used or abused as a dark field patch stop. Yeah. Yeah, and actually now you actually can see quite nicely that it did stain a little bit. Well, it did stain a little bit differently some parts. Yeah. Yeah. So. Yeah. Unfortunately, I do not have dark field for higher magnifications, only for 4 times. Yeah. And you see that the illumination. Look, there's also some dust and dirt. Where is my brush? Yeah. My desk is a little bit messy, so I don't have. Oh, here it is. Let's see, because yeah, there's a little brush, and I'm going to now brush the lens a little bit. Yeah, you can actually see it, that the situation does improve a bit. Dark field is very, very dust sensitive. Okay, very dust sensitive, and yeah. Comment about dark field. I know I'm sidetracking sometimes. You know that with light microscopes, it is not possible to see structures that are beneath the resolution limit. So you cannot see viruses with a light microscope. But with dark field, you can actually see them because they will show up as a bright dot, which is larger than the virus. It's interesting. It's a diffraction pattern that you see. So actually with dark field, it is possible to see structures that are beneath the resolution limit, but you're simply able to see a bright spot. Yeah, so this is interesting. Yeah, limit is 1,000 times. Yes, with my microscope I have a 1,000 times limit, but I'm not able to go with dark field that way. Yeah, so what I would like to therefore do now is a very last look at the stained leaf under the stereo microscope, and then let's move on. Okay, so this is now the stereo microscope. No, actually, this looks actually also nice. Just realized. Yeah. Yeah. Stereo microscope. Yeah. Top illumination, and now let's turn on the light from the bottom illumination. Yeah. This is actually interesting. I did not realize this is by the staining we can now actually see which parts much better I have properly processed and which ones I didn't. Yeah. 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 That's interesting. Yeah. Okay. Yeah. That's basically let's it with the leaf, unless you have specific comments or questions. Yeah. And I would say, okay, let's just move on a little bit, because this is also something that I have a little bit on my mind. Is I would like to do again some potato starch grains, but today with a little twist, because I would like to add some vitamin C. And yes, I have also done that before already, but every now and then I would want to repeat things that I have already done before, because they simply look interesting. Yeah. So what we're going to do is a big change in topic. Okay. And I just realized one thing before I do that. I didn't look at this. Do you remember what this is? Let's have a look at this first. Maybe not under the microscope, but I did not open this myself now for over a week or 2. Ah! The insect coming out. Evidently some kind of a mosquito or whatever hatched. Where is it? Yeah. Huh. Yeah, so there was actually some a little, I don't know. Yeah. Yeah, so that is the thing here. Oh, look, interesting. The mold started to spread over to the moss. Yeah, see, there's an insect in here. Actually, two. There's some interesting. I wonder what they are. Am I able to catch them? I don't know. It's gonna be. I mean, one way of catching those insects would be to put some alcohol in. You get the fumes and so on. Yeah. Yeah. Okay. No, let's not catch the insects. So it could be because not surprising. Yeah. But that's essentially the little how do you say terrarium that I made. And let's do now the following. I prepared a little potato over here, and the potato starch grains. We already know. But I would like to show you a little variation of the theme. Because, let me do that here. And I'm going to not put it in here. I'm going to put the starch grains with a little bit of water in here. All you do is you scratch it a little bit. So, there is a lot of starch in here. We can allow it to settle a little bit. I'm just going to show it to you briefly again, under the microscope, that how they look like. That's standard, so far standard stuff. But the vitamin C reaction is actually quite fun to observe. I hear the door again. Again, questions of which most of them are probably already answered. Thank you in any case. Yeah, my son is helping me out sometimes, and not sometimes, pretty much every time. Yeah, so over here, I just realized I ran out of small square. No, here they are. Here I got some ones here that I washed last time. Pop. And here we go. Where is the? It always takes me some time to. This is how do you say, the dark field again? Yeah. So here the starch grains, of course. No, I don't want to look at those. In dark field, yeah. Here we go. And here. How do I get them in focus? Yeah. Here they are, of course, nice and beautiful. Nothing unique, however. Very popular thing to look at under the microscope. Okay. So nothing special so far. Of course, I'm going to stain them now a little bit with iodine. Then they're going to turn black. So, and that's going to be our reference a little bit. Okay. So let's take it out again here, and let's put the on the desk here, and I've got a little bit of iodine solution, and have a look. Yeah, if I add a small drop of iodine here, it should turn black quite quickly. Okay, the classic iodine starch test. Okay, so let's put that under the if you. Luckily, the starch grains are a little bit more dense than the rest, so it's going to settle down here. And again, a small amount of this goes on a microscope slide. I'm going to do a very small amount, and I'm going to simply put that here also with a cover glass. Deliberately a very small amount. Flip. Yeah, and let's see. And we expect. Yeah, now I have to find a few of them. Here they are, right? Okay. very dark. That's typical. You know what? I'm gonna remove the polarization, the DIC. That's regular bright field now. And yeah, a slightly lower magnification, so okay, that's basically, here, look, here they are, right? So that's the standard thing. Yeah, so that is now what? Now I would like to do the following. I would like to add a little bit of vitamin C solution, and I hope I'm able to reproduce that, what I was able to do previously already. And that is because the vitamin C starts to is oxidized and starts to reduce this here, and therefore it will start, as it diffuses into the starch grain, it should remove the stain, and we're going to see if this actually works or not. So I'm going to keep it as it is, and I'm going to now go back to the desk view, and I'm going to prepare my vitamin C solution by adding a little bit of vitamin C, which I've got. This is, by the way, this is pure vitamin C. Yeah, so we're not talking about a vitamin C tablets, which contain a lot of, how do you say, other things as well. How am I gonna get this out? Where's my, I've got, see, I bought myself some spatulas, but if you don't know where you put them, yeah, now here they are, and I can't get them out of the box. How is that? Here we go. Oh, okay. So that should do it. And again, it's a little bit out of focus. Here we go. Add a little bit of water. That should do it as well. Yeah, let's try to dissolve it a little bit. Okay. And then I really hope it's gonna work again. That's one of the things that makes this live stream a little bit fun is that it's kind of very hands-on, and sometimes it doesn't work. The things that I want to show you, sometimes they do work. It's always a little bit of an uncertainty. Okay, so you see the vitamin C has now dissolved, and now what I'm going to do is I'm going to add a little bit of this vitamin C solution. I'm going to add a little bit of this vitamin C solution to the starch. Okay, and because I had a very small drop of the starch, the vitamin C solution should now be pulled in by capillary action beneath the cover glass. It's probably gonna remove some of the starch grains as well. Okay, as they kind of are being carried away. But we're gonna try it in any case. Yeah, if this is. Let's see. Did it actually go in? Ha. Okay. Yeah, they're being flushed away. But let's have a look at this starch grain over here, and let's really zoom in a little bit more. And it actually works. Look what happens. What do you notice? Yeah, as the vitamin C diffuses into the starch, it reverses the iodine reaction. Yeah, and that's actually also a little diffusion test that you can do. Yeah, so you see the smaller starch grains around it, they already have completely destained. But this one over here, yeah, is you can actually see how the stain starts to disappear. Yeah. And I thought this was kind of cool. Just wanted to show that to you. Yeah, that you're able to reverse the iodine reaction as well, with by adding vitamin C. By the way, for your info, that is actually a test that you also use in chemistry. Look over here, that you also use in chemistry to determine how much vitamin C there is in a certain substance. You can do a titration test. Look here. That's also nice, huh? It's on the other edge of the slide, and the vitamin C has not yet fully reached it there. Ah, yeah, you're discussing confocal microscopy. Laser scanning confocal microscopy allows you to actually produce three-dimensional images. It's super interesting technologies. Yeah, but look here. Yeah, we're now again reversing. Yeah. Yeah. And over here, this is where the vitamin C solution did not reach the starch grains yet. So there, yeah, it's on the other edge of the cover glass. The iodine, this is an oxidation reduction process that happens. And yeah. And the iodine seems to be neutralized by the vitamin C. Yeah. And so over here you see that essentially over here, it has already been reversed, and here on the other edge, yeah, it's still stained. Yeah, and I think yeah, over here, this is right at the border. No, I think I should be able to go now. I've got 60x, 60 times. Let's see how this looks like with, this is now with polarization as well. I don't know. Oh yeah, this kind of also looks interesting. Yeah, but I think you're seeing it better without. Yeah. Yup. Okay. So that is yeah. What time is it? Okay, we still have a couple of minutes. Yeah. You know what I would like to try? Yeah. We got that. Something I did not try yet. But no. Look. Why not? Why not try to add the vitamin C directly to this here? This might also be a possibility. Let's see if this works. Or I just pour it in like this. And maybe it's yeah. Or I can add a little, yeah, you see, it does turn brighter. Yep. So you see that we're also able to reverse this. Let's add a little bit more, yeah, a couple of minutes maybe. Or, yeah. Yeah, so you get the idea, yeah? Of course, we can also try it. I'm not going to be eating the potato as well. So, and see if the vitamin C that I added directly is able to reverse it. Yeah. Okay. So you kind of see that this is a basic principle. Maybe it's slowly. Maybe it's already soaked in a little bit into the potato. Yeah. Yeah. So this is basically yeah. Yeah. It works slowly. Yeah. So I'm going to now do the following. I'm going to read again a couple of how do you say a few yeah. Is it because vitamin C is no? It's because vitamin C is an antioxidant. So it basically it can be oxidized and it reduces therefore other substances. With oxidation reduction refer to electron transfers, and it means it changes the chemistry. Yeah. The iodine around so that essentially it's not able to make the color reaction anymore. So for your info, this is actually this iodine test is used, yeah, of course, to test for starch, but it can also be used to test for the presence of vitamin C. So you can do some chemical titrations this way. Yeah. So let's have a look here. Aha. From a mushroom, from mushroom gills. I tried mushrooms as well once, but I was not quite happy with the results. The mushrooms, some of them work quite well, but I was trying to also extract some how do you call this? Some spores from mushrooms, which I was not successful. Yeah. So yeah, there's some general discussion going on. And there are no questions for me. Okay. Yeah. So another thing in this case, because how many minutes do we still have? Well, we still have a few minutes. Yeah, you see over here, it already turned quite bright. I just want to show you something else, because these microscopy live streams are a little bit, how do you call this? Yeah, spontaneous. I want to show you something else here that I've done, and also not the first time or the last time, but I did discover something that I would like to share with you. And again, this is not something that I automatically always recommend because of health reasons, but I've been growing some mold, kind of successfully, as you can see. Now, which mold is this? This is the mold that is growing on citrus fruits. Yeah. What is this comment here? The pattern on the potato looks like a person with an afro hairstyle. Oh, gee, I'm not going to draw a face. What I just want to show you over here is what I've done is this is some coffee filter where I put some lemon juice in it, and I took a few a little bit of the mold from the moldy lemon, and I dipped it in here with a toothpick, and then after a couple of days the mold really spread quickly, and this is how it looks like. However, there's an interesting thing that I found out. And this one is already a couple of months old, and what I've done is I've made a new paper filter, and I transferred some of the spores from here to over here, and it did not grow. Yeah, so what you see over here is actually from a freshly how do you say, moldy lemon, which I dipped on here, and then it started to grow, but I was not able to cross culture it, which kind of surprises me a little bit, which kind of makes me wonder if those spores also not start to die off after some time, which is really strange. I think, and so that's the next thing that I would like to try, is if I'm able to subculture it. But when you have these things, you got to be a little bit careful, okay? Because those mold spores, they spread across, you don't want to inhale them, right? So I'm just saying, yeah, and you do want to keep them away from fruits as well, because otherwise the fruits are going to become moldy. But yeah, I'm doing some how do you say, crazy microscopy here, so why not also put this under the microscope, okay? How do I protect myself from those spores? By not, how do you say, throwing it around, yeah, and by keeping, letting the wind, no wind. The point is the following: if you've got moldy lemons or oranges in your refrigerator, there are the spores all over the place anyway, right? So, yeah, I'm just saying that this is something that cannot always be avoided, but I'm not. Actually, I did this once accidentally. I kind of bumped this here, and it was a whole cloud of spores was kind of spreading, right? So it is actually quite dusty in that sense, which you don't want. But what I'm doing right now is I'm going to take again one of my toothpicks here, and let's try to, I don't know, a little bit of water, and you dip your toothpick in water, I found out that these spores are a little bit hydrophobic. This means they don't always dissolve quite well. You see, yeah, it's now greenish. Probably more than enough. So I can already see the problem here that many of the, and yeah, something that I cannot show you today, but something that I am also going to do in the future is if you don't use water, but if you use lemon juice, what's going to happen is that, yes, they will start to grow, but not in the middle, but on the edge of the cover glass. I think this has to do something there where there's oxygen. Yeah? So I'm going to simply remove any excess liquid. because I would like to really go up with the magnification here. Yeah, cover glass should not float. It's, you don't want that either. Yeah, let's see how that works. Removing the and scope view again. Okay, I've got this now already at 60 times. And of course, finding now the focus is a little bit of more of a challenge. Are these the first? No, I don't know. Nope. Yep, here they are. Okay. And they're pretty small, and yeah. And this kind of also shows a little bit why they probably are able to spread over the air so easily. Yeah. Yeah. So these tiny little packets here, yeah, are the fungal spores. Yeah, some of them have already broken, are still connected together, while others have already broken apart. Yeah. Have you ever used clear UV resin as a fixative? Have used it for a few things and it works great. I did once buy a UV nail polish, and this actually was a little bit too thick. Yeah, it was almost gel-like, and therefore I did not. It did not work quite well. Yeah. So, but otherwise I've not used UV. Yeah. Yeah. So. Yeah, so that is basically, and we can change the color a little bit around here as well. Yeah, so yeah, you see, in relation to those starch grains, they look quite a bit smaller, obviously. The UV resins for making things like key rings or okay. Is this a little bit like similar to this 3D printing type of thing, where you're actually using a UV laser or something like that to make products? Yeah. Okay. Interesting. No, did not try that. Yeah. 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 So basically, just wanted to also share that with you a little bit. Yeah. Because yeah, I did not put those when I've grown it. I did not put those under the microscope yet either. Okay. So let me quickly check that. How do you say this? The questions that I've got here. Yeah, there are a few, not so many, but a few questions. And let me see the time. Yeah, in a few minutes, I'll call it a day again. And yeah, I've tried all kinds of cameras. If you just want a convenience, there's a USB camera question. If you get a USB camera that connects to your laptop and has software included, if you want the very best quality photos, then nothing. Okay. So that's a general comment about microscope cameras. Yeah, this 3D printing filament is an interesting idea. I've not used it, and I didn't even know that this exists. And the reason why this is interesting is because I've already been wondering, how can I get some kind of a conductive material laid on top of a microscope slide? I've been actually thinking about doing there's this possibility using silver nitrate and then kind of doing a chemical reaction, and then kind of the silver is deposited on here or something like that. There is this process which is way too complicated. But having electrodes on a microscope slide would be actually a very interesting thing. And I mean, I do have a 3D printer, and being able to maybe print a certain pattern on here would be kind of interesting. Yeah, not only electrodes, but yeah. Gosh, I've got a crazy idea. I mean, you know what you could do? This is a crazy project. Maybe some of you could try that. What you do is paramecia, they move towards the negative pole. If you've got one over here, negative, positive. And then you have some kind of a joystick, and you're able to maybe you're able to remote control a paramecium on the slide. Yeah, by alternating the current, the voltage. That would be quite interesting if that would work. Yeah. But yeah, I'm gonna have a look at this because having a 3D printable filament, which I hope could be printed directly on a microscope slide, would actually make a lot of things easier. Yeah. What chemicals can we use to stain the leaf's skeleton? Please, I use Crystal Violet. Try regular fountain pen ink. Try it all. I think, yeah, water-based inks should work because, as a matter of fact, those veins are able to carry water, so they should be they are hydrophilic. It's made of cellulose, so water-based stains should work. Yeah, grape leaves, I don't know. Yeah, they're much thinner than maple leaves, so yeah. I talked about the hydrogen peroxide. Okay. Yeah. Again, this is the 3D printing here. You can put a copper wire to a soldering iron and use that. Oh, that is about testing for microplastics. Okay. Okay, okay. A copper wire. Okay. Yeah, they have to be pretty thin so that you're able to actually touch the microplastic filaments. Yeah. So yeah. Okay. If you look up printing circuit boards on glass, I didn't know that this. Okay, never thought about that. Okay. Interesting. Printing on glass. This is something, yeah, which would be kind of interesting to do. I'll have a look into that because it would really open up a whole bunch of interesting interesting possibilities. What I've been trying to do so far with galvanotaxis is kind of using some wires, and I tried to use hot glue to fix the wires here. Difficult to do. Or also aluminum foil that you use for wrapping the sandwiches, yeah, which are fairly thin. Yeah. So that is all I have experimented with, but this is all very imprecise, right? And it does not allow you to give you a very uniform thickness as well. So in that sense, maybe being able to 3D print something directly on a glass slide would be quite interesting. Yeah. Yeah. So I think, what time is it? Yeah, it's yeah. Unless you have any specific questions or so. What time is it? Yeah, it's 1:22. Otherwise, I would slowly consider calling it a day as well. Okay. Yeah. What else do I have here? This one is over there. Let's see. This one is here. I'm just checking if I've got everything around here. Yeah. Yes, this is the thing that I wanted to show you. Last thing for the last 5 minutes. I just a few days ago uploaded a video on this channel about really bad looking apple juice. Right? Have a look at this. Yeah. And look what happened in the meantime. This is a mold. This is bad again, pretty bad. And yeah. So this is something where you have to be a little bit careful, and yeah, you don't know which mold it is, but this fungus, yeah, looks also quite interesting under the microscope. And I did actually already put it in there, and it's a, how do you say, quite a pretty specimen as well. And because we still have, let's say, 3 or 4 minutes, why not give it a last try? Let me see. I need a proper microscope slide here. Let me use this one over here. And let's see if... Yeah. Yeah, sometimes it's a little bit of luck if you're actually able to catch something. And if not, it's also fine. Let's see. And scope. Yeah. What you see in the background here, just going to show you, these are mostly, I think, yeah, from the liquid, these are mostly bacteria as well. Yeah, so you see, this is the reason why you should not drink any spoiled food or anything, because all of those dark dots that you see floating by, most of them are actually bacteria. Yeah, so this is, yeah. And one of the things what fascinates me all the time is that, yeah, the majority of those have not yet been identified. We don't know, yeah, because many of them, around 1% of the, or less than 1% of the bacteria can even be grown in pure culture in the lab. So what you see over here, yeah, many of these tiny bacteria here don't even have a name yet. And this is one of the things that fascinates me all the time. You don't have to look very far. Plenty of things still to be discovered. In case you wonder, I'm looking right now at this using phase contrast 40 times. Millions of bacteria, yeah, which most of them shall remain nameless. I'm saying this because I often receive questions with pictures and they ask, okay, by looking at it, which bacterium is it? I'm telling you, well, not only do we not know, but for some of them we might never know because we're not able to grow them. Yeah? So what scientists do, they do direct DNA tests on them. Yeah? But plenty of things still to be discovered. And that's actually maybe a nice closing comment. Yeah, it's one of the things that fascinates me all the time is that there's still so much unknown out there. So, yeah. So I will tell you the following. Growing unknown mold and bacteria would put you in biosafety level. That is correct. This is biosafety level 2. Strictly speaking, every time when you leave food out and you spoil it, you're in biosafety level 2, right? So this is a little bit of a thing here. Essentially, yeah, growing bacteria and fungi, we are all doing that without knowing it. And if you, for example, have a compost heap, as a matter of fact, also if you throw your compost into a compost container, you're essentially multiplying countless bacteria. What is important is you're not allowed to grow them in pure culture. Yeah, so it's biosafety level 2. That's why I also discourage this from essentially, from doing at home. However, if you let some apple juice or some milk or whatever stand at home, what will happen is you will grow unknown bacteria. Yeah. So that is, that's basically, something that, and if you throw it out immediately, yes, where do you throw it out? You throw it out into a trash can. And then essentially you continue to grow it there, right? So that is a little bit, I would say, a legal loophole maybe. But one of the things that you're definitely not allowed to do, and that's why I'm also not doing that, is you're not discouraged that from doing very clearly. But unfortunately, I've seen people do that. It is growing bacteria from your own body, right? Fingerprints and so on. You should not be doing that because these indeed are bacteria that can potentially grow on you and could be potentially dangerous. So that is a clear no-go. Yeah, just want to say that because you have to be careful. Luckily, I am a trained microbiologist in that sense. So what I know is I know how to properly dispose of these things. Yeah. Food goes straight in the trash, of course. And what you have to do in the refrigerator is you have to also keep, for example, meat and vegetables that you eat raw. You have to keep that separated. It's very clear. Because essentially, if you have raw meat juice and getting in contact with raw vegetables, for example, it's something you don't want. Yeah? So that is just something that I would like to, saying that lemon mold growth isn't technically it's biosafety level 2, and indeed that is something where I also have told my students because they also asked me, can they do that? Well, it says no, you shouldn't. But these spores that I have over here are on a lemon, right? And therefore, actually, strictly speaking, you know what they are. Because there is one type of mold that actually grows on lemons. It's actually a very common one. Yeah? So what I'm going to do now is I'm going to, can UV light kill them? Yes, it can. Yeah. So, but you will not see that how they're being killed under the microscope because it destroys the DNA. Yeah. So I'm going to call it a day for today again. It's been again an hour and a half. Yeah, I'll think of again something for you to show you next week. Okay. I wish you all the best, and yeah, I'll call it a day today. And for the closing picture, let's put put in the leaf skeletons again here. Yeah, I wish you all the best. Happy microbe hunting as always, and hope to see you again. Bye bye.